So we've covered our introduction to logarithms. What I'm going to do in this video, I'm going to set you a few questions. I want you to read the questions, pause the video, have a go at them, and then come back and check your answers. There's a few simple ones just to cover the basics of it. We'll get into much more in-depth, complicated things involving these a little bit later. So here they are. First, I want you to take the three expressions I've got at the top and write them in logarithmic form. So 6 to the power 4 is 1296. 9 squared is 81, and 6 to the power 1 is 6. And then I want you to look at the two functions I've given you in question 2, so y equals log to the base 3 of x and y equals log to the base 10 of x, and tell me two key points on these graphs. So you don't have to work at every single point on it, but think back to the graphs we drew and think about the key points we marked on there and tell me what those key points would be in these ones. So pause the video and have a go at these. Okay, so let's have a crack at question 1. So first one was 6 to the power of 4 equals 1296. Now remember, logarithmic form is when we have something equals log to a base of something else. So x equals log to the base a of y, something along those lines. And remember, we could take an expression that's written as x to the power of a equals y and write it in that form by doing a equals log to the base x of y. That's how we turn it into logarithmic form. So we have to follow that same procedure for this. So x to the a equals y, 6 to the 4 equals 1296. It's then just working it through from there. So the power becomes the new part here on the left, so it's 4 equals, it's then log to the base of what the x is, and in this case the base is 6, so that gives me log to the base 6 of 1296. And you can check this, make sure of it with your calculator. Second one, 9 squared equals 81, we follow the same logic. The power now becomes our new left hand side, and our base here becomes the log part there. So for this one, the power becomes my left hand side too, it's then log to the base 9 of 81. Last one here, 6 to the power of 1 equals 6, so my power is 1, that's my left hand side, my base is 6, so 1 equals log to the base 6 of 6. So there's my third one right there. So that's the three of those in logarithmic form. Fairly straightforward if you just follow this procedure and this formula part here. Now, second question was two key points on these graphs. Now, remember when we did the graph before, there was always two key points. The first one always occurred at 1, 0, because if we take log to any base of 1, we always get a y value of 0. And the second one occurred when we had a y equal to 1, when we had y equal to 1 value. We got a. Now, a came from the base part here of our logarithm. So that's where the x-coordinate part came from. So for this one here, the y equals log to the base 3 of x, our first key point was the 1, 0. Unless we do any form of transformation on the graph, which we're not worried about in this video, we're always going to get 1, 0 being our point. The second one comes from the base of our logarithm. We get the a, 1. Now the a comes from the base. In this case it's 3 and the y value is 1. So my second point that I'm after is 3, 1. Second graph is y equals log to the base 10 of x. Again, our 1, 0 is going to be our key point on this graph. We've not transformed it in any way, shape or form. Second point comes from the base. So that's the x value. Our base in this case is 10, 1. There are two key points there. So whenever we do the graph of a logarithm, these are two key points that will always be marked on. Now obviously, when we do graph transformations, these will change and move a bit, but we just want to make sure we've got the basics in this video. So, hope that went well. See you in class if you've got any questions.